automatically. Whenever you type, it's automatically build. That's the reason first time when you create the template, if you type something, won't show error message. Because it's kind of interpreted. Okay? So you don't have to worry, build. You can set up, change the configuration. But as a default, it will compile automatically whenever you type. Okay? So after you type and complete the code, it's already create the class file. Then you can build the jar file. Okay? To do that, you need to include some library that should be included in as a shared library for your jar file. Okay? So some configuration should be done as a property. Okay? Then you can get the benefit of the using ID. Okay? Also, if you are not sure what is it, if you are using the customer, the input format, or the whatever, but you do not know actually where it is, it will show the bubble pop up, or you can use the. But I'm not familiar with the Eclipse. Do not ask the details of the programming itself. Okay? But I believe the GA, they are better than. Then finally you can export to the jar file, like the jar CVF command. But at the time, it doesn't have to be the runnable, it's just the jar file archive. Okay, then you can specify the location. Then after you create the jar file, go into the command line interface terminal. Then run header command. Then run. So you will practice the implementing protocol using Eclipse the setting. It's not a problem if you build your project using the Eclipse, it doesn't matter. The jar file that you create by the Eclipse should be running on file. There is a new version of the API, so I'm not going to explain details, so you don't have to worry about too much, because you do not have experience on old API, right? So that will make. But anyway, the map current version is map reduced version 2. That is yet is called the yet another the resource manager. So that actually separate the resource manager part as a separate part. The old version MRV1 actually include the resource manager inside. That actually prevent to run the map reduced system non-Hadoop system. Because the resource manager only deal with the Hadoop HDFS file system. But after separate, it can be running on local file system or other file system also. But most of the production system, they are using the MRV1. So if you have planned to implement your real production or the test on your research, so I suggest to use the V1 so far. Because the V2 is not where the review is. So next topic is unit testing. Anyone who ever tried a unit test? Anyone who knows the unit test? What is a unit test?
It's like a process to test our code that we
Test codes.
Yes.
In general, test code. Yes. Then how?
What do you mean by how is the process?
Yeah, how to test? Everybody want to test before you.
We provide some like data. We can test the code, so we see the result and compare the result with the actual result.
Okay. So you test when you have the, so probably you will join one of the big projects, right? So probably you don't know what is the big picture of the entire system. Instead, you are going to implement what you are in charge. You are in charge of the specific part. So it's very hard to test the entire system at once. So you can, after you build, so for example, my job is to implement algorithm 1, algorithm 2, algorithm 3 part. Okay? So first I try to do some input which is from the other data. So the friend developed. So at the time, so if you want to test, you build all these algorithms and combine with the entire system with your friend, then test the entire system. It takes a long time. Also, what if it will learn the running time is 1 hour? You should wait on 1 hour until you realize whether there is a problem or not. So it's not convenient. Okay, so it's not practical. So instead, the input of this one is what, for example, so average. Algorithm 1 is the average, so you give the sample data 1, 2, 3, then test manually, not from the other input. In your code, you can specify the input 1, 2, 3. Then output is expected output is 2, right? Average. So compare whether output of algorithm 1 is the same as expected output. This is called unit test. So it's kind of the software idea. So this unit test is very, very important in this project. In your classroom project, sometimes it's overhead, so you can just ignore and just code from A to Z, and you get a bunch of error messages, then try to solve one by one. Sometimes it works, but in this project, I don't think so. Okay, so you are familiar with such a unit test in Java. That is what? The Java unit test. It's the J unit. Okay. So anyone who used the J unit? Map reduce has the same idea. Unit test. Especially as you can see from the source code, there are a bunch of input and output, input and output. Actually, the first difficulty when you are coding the MapReduce program is how to handle input, how to define the output. So, bunch of input and output. So you can make the unit or test unit, then test the unit by unit. Then you can eventually focus on the algorithm. In word count, algorithm is simple, but in real project, it's much complicated. So even one algorithm has a bunch of the small input and output. So you can test the MR programming. Such a unit test is called MR unit, which is based on the Java unit test. So if you are already familiar with Java JUnit, it's almost the same. They are not the same class, but their idea, interface, the syntax are the same. So, if you are not familiar with the unit test, please, over the summer, why don't you try? So, how can we do that? Let's take a look at. There are two parts. One is a test. So, this one is a Java annotation. What is the Java annotation? This is not the real code. It indicates this is not real code. It indicates the method that you are going to test. So assign and test it means, okay, this is not real code. This is something additional, but it's for testing the unit. So J unit will be called. Okay. Then before it, the add is also Java annotation, and you need to. After you call the J unit, okay, then the result will be compared. So we will see the example of that. So this is the J unit hello world. Okay, this is only for J unit. So we will specify hello world as the input string. Okay, you don't have to read the data. Okay, from the HDFS, even local file, no. you specify input data here before, okay? So Java annotation and test this one. So this is your algorithm. So lower to make the lower case. So our expectation is this one. Okay? Then compare using the assert equals the method of JUnit. Then whether that is the same or not. Okay? That's. What about the Eclipse? Eclipse fully support much more even. So if you wanna implement the MR unit, using the JUnit, you can just click, several click, and you can make the actual template of the unit test program. Then just add the Java annotation to specify what is the input data. You don't have to provide the input type or format. Okay, no, just the sample data. Then test it. At the time, you can use the Eclipse and run directly. Why? Because this is not real program, MR program. This is a unit test focusing on whether my algorithm is working well or not. So this is an example of the mapper unit test. So this is a test word count. Okay? So mapper driver is like this one. We define, and instead of read the data from the file, okay, instead it will be here. Tab the text input will be specified. And so mapper drives the read input method. Okay? There's a expected output is a cat. No. This is the
driver. The intermediate.
Oh, this is a mapper.
Yeah,
Okay?
intermediate.
Yes. This is a mapper, so can run and run test whether this is the same as this one. Okay? Compare. So you need to code the MR unit. You need to import the MR unit. And you use map driver. Okay, this is the same as the mapper driver. And before annotation, you need to set up the test. Okay, so then you need to give the sample data as a text. That object should be the same as this one. And this is the output, so you need to test whether they are the same or not. So these are the methods that you can use in the MR unit test with the input and with the output. You can add more input if you have a new line. Like you can pretend a new line record. And run test or run test is you can verify the output. Run means it's just run the program. You can print out or you can see manually compare whether it works or not. In using Eclipse is much easier because it's a fully support the JUnit. Otherwise, you can run in the command line. So job is, as you can see, there's no header command because it's not real MI program. You can just run as if you are running Java program. So Java, okay. So you can test the MR unit on your next exercise. Okay.
So,
Yes.
do we have to use it?
No, it's not required. It's up to you. Okay. When you develop your project. Okay.
Yeah, because you need to compare the value.
Then you can manually, yeah. So that's what I'm saying. Sometimes I understand. So in real project, I never use the unit test. I'm not a developer. But this is good for when you are doing the big project or very complicated algorithms. Okay? So if you are not familiar with this one, if you never use this one, probably you will never use the future. Okay? But if you are familiar with this one, it will be very, very convenient, I believe. Okay? Yes.
It's easier than debugging.
Yes.
Yeah, it's much easier than
Especially those who are not familiar with the debugging, right? You receive bunch of, even though there's just a simple error, the warning and the error message are 100 or sometimes.
Actually, the unit test benefit for unit test after define the code in the future.
Yes.
So when you set up the code and running and match the unit test, then the future update something, the run test, and regression.
It's up to you. Okay, so we will continue the additional topics in the MapReduce program. First one is the tool learner. It's still MapReduce 4. We need to do 5 and 6. So, what is a tool learner? After you, sometimes you can use the MR unit or without MR unit. Anyway, you implement the Lecture4.2, the MR programming, then you try to run. Before you run, probably you need to test. This is the idea. When you run the MapReduce program, do not test directly with the real data. Real data is 1 terabyte or sometimes petabyte size data. We don't know. It takes several hours. Then after several hours, you realize there is an error. So you need to do again. So it's a waste of your time. So you better test with a very small size of data. Also, if you have only production HDFS, so you don't want to hurt or you don't want to waste of the real production of this Hadoop system. Is there any way to test with my local file? Okay? Local file is the part of the real HDFS file. So to do that, so there is a way that is the tool runner. So tool runner is a MapReduce programming, unlike the JUnit. JUnit is not the ML program. Okay, it's a unit test. But this you have the jar file, but I wanna run this program with the local file, not HDFS. At that time, you can use the tool runner. The tool runner is not using the HDFS. Okay? So at that time, you need to specify in your driver, you need to change. This is the word count. So you need to configure, implement tool. Okay? Which means tool is pure Java. It's not the Hadoop only. So if you are not sure what is a tool, why don't you check the website or the Java group, whatever. Okay. So we can main method, for example, word count, the main method not work with the HDFS, the system. Instead, it will be the runner in local file. So this is a tool runner. So you can create the main, or this is another way. So you can create a tool runner and make it runnable. And that tool runner is defined here. It's a similar as one. Thread. When you implement the thread in Java, it's a similar idea. So you can make the thread directly like that, or you can make the algorithm, then make it runnable. Okay? By calling that thread. It's a similar idea.
tool runner is like the thread.
Actually, I guess it's actually motivated by the thread, but it's not thread. But we can consider all the Java process can be as a thread.
Yeah.
Actually, they are thread. It's a thread at the time. But when you learn the thread programming, okay, so you specify something algorithm here.
Right.
Then you code that one thread and make it runnable. Yes.
Sir, doing monitoring program,
This is a multi-thread program. This is a different, but for your understanding, it's a similar idea. So you can run the tool runner this way, or you can make the main method as the runner tool. Okay? Either way is fine. For what? That's more important.
Yeah.
To run your MapReduce programming with the local file, not the head cluster. Okay? So this is the entire code of the driver. So in your driver, so you can make the public runnable the word count main object. So this one will be running on your local file,
Yes, sir.
not HDFS. Which means actually without this one, when you implement the word count for HDFS, who is controlling such a runnable or whatever? Some software will control. Right? But this time we are not going to use this resource. Instead, it's a
So it's
runnable
like
in the local file.
any program.
Yes. But it will use MapReduce library. Okay? Not HDFS. The other part is the same thing. You can see you can set the mapper, you can set the reducer, okay, and input and output format. It's the same, exactly the same. But this is runnable on local file system. At the time, how can we run? You can use header command, but it will not go through the job track or whatever. It will running on the local file system. At that time, you need to even specify the reduce number of reducer. Why? Who decide the number of reducer? Driver will decide based on number of block, but you do not access the HDFS. So we don't know how many reducers. So you can specify here. And also, my input is a local, output is a local. Okay. Also, you can specify any configuration when you run this one using -d command.
So, Professor, the 10, when you say the reduce 10, so you have 10 reduce.
Oh yes, you can specify the reducer.
Like, would it run in parallel?
That parallel is not important here. So here you need to check the algorithm. To check the algorithm, not performance.
Yeah.
So for example, your real file size is 1 petabyte size, but I don't want to test with 1 petabyte size data. Instead, 1 megabyte. Okay? So parallelism is not important.
Because you're testing.
Yes. So you will test the tool runner in your, I'm not sure, there's no practice for tool runner. So this is the main topic of today's lecture, combiner and partitioner that I introduced. So today I'm not going to have the break time, so if you want to, you can go to the bathroom or take a break or get your phone call, but do not bother others. I'm going to keep lecturing. So combiner, in short, in case we have
multi-nodes.
no, this is the partition. Combiner is for to reduce the drop or the reducer. Because the reducer, as you, some of you guys already guessed, is a what? Bottleneck. Okay? It will be the overhead. So why don't we reduce the drop of the distance? So sometimes the combiner is called mini reducer. Actually, many of the time, most of the time, combiner class is the same as the reducer. You don't have to code it again. Just run it, but locally. It's running on locally. So it's called a mini reducer, but it's running locally. with the node where mapper is running. After mapper is done.
Local means in the HDFS.
Which one?
In HDFS. I mean in the node. It's not local, I mean it's not
Local means local block.
Okay.
Yes. In this block, there's the task tracker. So which means mapper is running. And there's the intermediate output. When you got this one, you can run reducer only on one node locally. What is a reducer in WC? Sum of value, right? For the same key. So without combiner, it will send, for example, A, 1, 1, right? It's an intermediate format. But if you run the combiner, it will be changed as A, 2.
It's dependent on the sum or average, right?
It depends on your algorithm, but it will run the same algorithm as the reducer. So that is the reason it's called a mini reducer. As you can see, the size, network transfer size will be reduced. Also, it will reduce the overhead.
But it will be done after the shuffle and so on.
No.
The reduce, the compiler should be run after the shuffle and so on.
Oh yes,
Yeah,
because for example, you have the A1
yeah. Then you need to combine.
and the next A1, you need to find each A. So it's the after the shuffle and sort and at the read. So output from the combiner is sent to the reducer, and input and output type and code are the same as the reducer. Okay? So most of the time, combiner, you don't have to code it again. Just code the class name of the reducer. So this is mapper, this is a reducer that we have seen in WordCamp. And this is the out input of the mapper, this is the output of the mapper. Okay? Right? Then this is the intermediate data sent to the reducer. As you can see, it's 1 and on 1, 1, SAT 1, 1, and the 1, 1, 1, 1. Okay? So much longer size. In terms of traffic, it's much bigger than this one. So this is actually final output of the reducer,
Yes.
but in combiner, if we are using the combiner, it will decrease the job. It's already done in
Yeah,
after the shuffle and shuffle, right? Then if you send the go and for, it's a much reduced size, you can reduce overhead. When you have a multiple block, so they send, so what you need, what the reducer need to do is combine the from the here, the from the here, the from the here. You don't have to add up the 1, 1, 1, 1. Right?
So it's like to get the final result.
Yes.
Instead of more jobs.
Yes, sir.
but I think the combiner will be better. Of course, if you use it in more complicated.
Yes. But you should be careful when you are using the combiner. For example, sum of the data is okay. How about average? Average of the data. Okay? So for example, T1, so A. So I will
That one.
ignore the key, only the value from node 1. So you have such a value. So without combiner, and reducer will receive all the value. What is the output average? So 8, 18, 27 divided by, is it 27? 18,
18 and 9.
27.
Yeah,
4, 27 divided by 4.
Yeah.
What is value?
6.25,
6.25, right? we apply the combiner. So combiner, what is the average?
No,
So 6.
Yeah.
What is the average? 9.
Yeah, yes.
And what is the average?
Yeah, 7. 7.7.
5.
You have
So
to be-
this time you cannot use the combine. That is the same problem of the reducer. Not all algorithm can be converted to the map reducer program. This is for you can apply combiner only for commutative plus associative. So you are not sure what is the commutative and what is the associative. Listen. Average is not associative. Okay? Yes.
Professor, just a little bit confused. Like in this case, it's combined before it leaves the node, right?
Yes.
But it should be like so. The shuffle and sort. What is it? Is it like
Shuffle and sort only the shuffle and sort the data by key. Okay? It doesn't process any other key.
Right.
Just
If you want to process it in advance, you can use combine. Otherwise, reducer should process, analyze the data.
Okay. Can you use combiner after the shuffle and sort? Like the example you showed us before.
Yes, you can do that. But in case this is for algorithms testing.
So you can.
Yes,
use
if your algorithm is average, okay, at the time if you cannot apply the combiner
Right. Oh, okay.
because that is not associated.
Yeah.
So only your algorithm is commutative and associative. Like this one, you can apply the combiner. It's the same problem in the map-reduced programming. Somebody believe map-reduced programming is the general solution. No, no way. Some of the algorithm can be converted to the map-reduced programming. The others are not. There are some programs you cannot apply the map-reduced program. Okay? Just like when you are using the parallel programming, some of the algorithms are working well, but sometimes the other algorithms takes longer time than single loop.
But you cannot like make the reducer work until it receives like the lower level. It has to be in the local.
I don't get your question.
Like in the first example you gave here, Professor.
Yes.
When you
Count.
when you made it count, it's actually the reducer was actually in the data node. It was like
Any reducer is one of the data.
any data.
Yes, it doesn't matter. This is an algorithmic problem. Okay? Your algorithm, your business logic.
Yeah.
Okay, maximum combiner, no problem. Right? You can, maximum is commutative and
Yeah,
associative.
that's no problem.
But average is not the associative. Should be in all together at once. So you should be careful when you apply the combiner, whether your algorithm is commutative and associative. It's the same problem when you decide to use the MR programming. Some of the algorithms doesn't fit to not fit to the map reduce because of this kind of problem. That's the same thing. Okay? That's the same thing in parallelism. In parallelism, sometimes if you want to look up the other program, like when you have the cluster like this one, if you look up the other program, there's much overhead because they need to see each other. There's overhead. So you need to consider such a algorithm to apply the map with this program. Okay, how can we specify the combiner? It's a job method. There is a set combiner class method in job object. So you can specify. Just one now. Okay, you don't have to code it again because it's the same as reducer. Okay? So you will see in the exercise lab on Thursday. there is a additional method.
Excuse me.
In your program, yes.
Regarding to the problem, the associated and unassociated, the reducer will not get this problem.
What does that mean? We last submit the problem.
I mean the average.
Reducer?
Yeah.
I
Because
mean, you
the-
can run the program, but the output of your reducer is not expected. Okay? It will be different value. Okay? It will process, but it's kind of the logical error, not logical error.
So that means compiler is like a test. Because regarding to compile result, we can expect
You cannot get any message.
message.
Just you will get the result, but that's not expected. Okay? You should be careful. Okay, so sometimes when you run any program, you can specify the environment or parameter value, configuration. Okay, how many register, how many the process or something like that. So sometimes you can specify such a configuration in your source code. Right? The problem is you need to compile every time. What if when you run, you can specify the option for parameter value as the argument of your process. Right? So, but you can specify, you don't have to compile it again. However, at the time you need to specify that option whenever you run. If your option is in general, you can specify in your system. Right? So that's the same thing in the Hello program. So you can set up, actually configure your configuration and different level. When you set up, when you install entire Hadoop system, you can change the, in general, global parameter value you can set up. When you run your program, you can specify the option using -d option. Don't be confused with the d option in Java if you are familiar with. That do not use minus something. And there's no space for the option. But -d,
It's be default, right? Default setting.
yeah, default setting, right? So don't be confused with it. So this -d is for Hadoop command. Or if you want to specify your option in your program, at that time you can use the set as the context the object. So initialize the data structure or the read data from external file or set parameter value. It can be used for various ways. For example, what does that mean? The read the data from external file. I process this one word count.
Yeah.
And there is a lookup table in the HDFS or local file. So whenever you have the R, checker lookup table, and this is going to be is. This is a lookup table. So how can you specify? You can use such a configure setup. And or some other data structure or object file you can specify in the setup. Okay, setup method. So can be. Also, if you have the, I'd like to specify the number of reducer. I'm not sure whether you can change the option. And if you don't want to use such a thing, you need to clean up. Why? This kind of a setup context will reserve memory area. Okay? It will run with on top of Java virtual machine. Java virtual machine will reserve memory. Okay? That is the reason. As a default, it will reserve 32 megabytes. I'm not sure. There is a specific size of the default size of Java virtual machine. When you run the very, very heavy Java programming, it will exceed the limitation. At that time, you need to specify the default size 1 gigabyte, something like that. When you run Java program. So similarly, when you run the setup and when you instantiate the setup, It will reserve the certain area for Java. For example, I'd like to read the external file to the context. It will reserve. It will read in Java virtual machine this much. After you complete that one, you need to clean up. Otherwise, it will reside on your memory. So it's a waste of resources. That is the reason you need to use clean up. That context. Context is kind of open area. So you can do whatever you want in the context. Put the object file. You can put the text information. You can put the number. You can put the configuration file. Whatever. How can we create that setup? It's the this is the wrong way. I will give the 1 minute, 30 seconds. Why this is wrong? Do you think you get the compilation error when you compile this one?
No, there's
No compilation error. No problem. You can define the static, it's a global in this class, right? And you can specify the value. And you can the value like this. Then why this is the wrong way?
because they are locating the environment every time.
Anyone? I will give the extra point if you find.
So void mean certain. I think it's public static. Void means certain value.
Actually, there's no error. In terms of syntax, it's okay. No? Hint. If you're running this program on your local machine only without HDFS, there's no problem. After you compile the my class, how it works? Client will send my class object file to each node. This class, my class is here, also here, also here. And then you define private static parameter here, parameter here, parameter here. It can be 5 here, but it can be 6, it can be 2.
Static share.
They do not share the information. You don't know which one will be parameter, right? So this is not a right way in a MR program. Okay? Instead, because we have multiple nodes, okay? They share the same object file. Not actually share. They run the same object file separately using what? Java virtual machine. Okay? So, how can we address that problem? We need to create context. We can use context. Then communicate through the context for that parameter file. So, if you use this one, this object is this context object is kind of shared area in your Java virtual machine. So if this one is set 5, or Java virtual machine is set 5 through the Java virtual machine. Okay? So at the time you can use this one. At this time you need to set the value parameter 5. Then all nodes recognize such a value. Not useful like this. Why? Because it will be overhead between among the nodes. Similar idea was done in RMI. Remote RMI in Java. Remote. I forgot the name. Whatever. Anyway, this is the right way to share the parameter value using the setup and context. Okay. Next, partition. Partition is in case you have multiple reducer, you should know where this key is going to, right? At the time, you need to specify so you need to implement such a partition to divide the key and value, the pairs. Okay. This time we use the hash code, which means it's randomly distributed by the number of the reducer, right? So you can specify the number of reducer tasks. This is the module, right? But sometimes you want to keep only Monday, or sometimes you want to keep only A to N. So at that time you can implement such a partitioner. In this case, this is called the hash partitioner, which is default. So randomly distributed. Actually, it's not randomly, it's based on hash key. And this is my common question, what is hash? So you need to look up your algorithm book, what is a hash? Hash is used to all up, frequently used in computer science, but not many computer science students know about the hash. Okay? Yes?
So this is the part of assigning which block should be after the intermediate. You also assign which reducer.
Yes.
Right?
Yes.
So in the code, where is the assigning the reducer? I mean, intermediate point. Where?
This one?
Which part?
This one?
No.
Where?
So I think how we can know which.
Oh, we will see details about the code. So this is the high level code of the partitioner, but in this case it's a hash partitioner. It's kind of randomly distributed. Okay? But if you want a special value of that, you can make a personal partitioner. Okay? So it's the extension. You need to code the partitioner class. Then you need to specify this partitioner class on your driver using the set partitioner class. Okay? This is one of the examples of a partitioner. Okay? Separate file. Why it can be included anywhere as long as it has the class. Okay? Then this partitioner has the key and value. Okay, then you need to specify configuration. Here you need to set up, you can specify the algorithm or the setup. You can, for example, if the key is A, then the reducer number 0 to n minus 1, and is the reducer name, reducer number. So you can specify that one over here. Okay. Then you will see the example of the partitioner during the exercise lab in the next class. Once you see the real example, it's quite straightforward. Okay? You can just specify based on the condition, specify partition the reducer number 0 to n minus 1, and it's the number of the reducer. Otherwise, you can use a hash partition. It's a random using hash key randomly distributed. Okay, so we're pretty much done for the basic part. Also, sometimes you wanna run HDFS command, like the read the file, create the file, delete the file. So how can you manage the HDFS? Using Hadoop FS command. You can upload, you can download, put get, or cat, or create for file, you can do that. What if you want to do the same thing in your MapReduce program? So this one shows the how to handle the HDFS, the command through the MapReduce program. Okay, so that is the file system FS. Then we can specify. So for example, this time we can get the path of the file. Okay. If you want to write the data to the file in your code, MapReduce programming, you can create for FS. FS is the file FS data output stream. Okay, I don't know. FS, yeah, file system. Okay. Also, sometimes we can communicate between the nodes using configure with the setup method. There is another way to share the data that is called distributed hash for lookup table. So configure in use with the setup can be used general. It's